Assessment 2 for wireless network technologies in MSc IT mainly focuses on wireless communication and the technologies and applications of wireless communication. This consists of 4 subsections. Section of Assessment 2 that contains several topics discussing about different versions of IEEE 802.11, which is the IEEE standard for wireless communication, and the architecture of it, including basic service set and extended service set, and the MAC layer and its frame format. Also, we are going to discuss about IEEE 802.11 physical layer, and finally a form of wireless communication will be discussed, that's Bluetooth and its architecture, layers and the frame format will be discussed. The first thing that we are discussing is IEEE standards, different standards for wireless communication. Under that we get few. First one is IEEE 802.11, which is not being deployed now because of its low speed, which offers 1 to 2 Mbps transmission speed, which is not suitable for modern transmission, modern data transmission, so therefore it's not being deployed now. And here we have another version, another standard 802.11a, which offers speed up to 54 Mbps in normal 5G gigahertz band, but it's incompatible with the 802.11b and 802.11g wireless standards. Another standard of wireless communication is 802.11b, which provides maximum transmission speed of 11 megabits per second, and it uses 2.4 gigahertz radio frequency range, but it's compatible with the IEEE 802.11g standard. Actually 802.11g is the popular wireless standard today, which offers transmission speed up to 54 megabits per second, and also this operates in 2.4 gigahertz band, and also it compatible, as mentioned above, it is compatible with 802.11b standard. And the latest standard is 802.11n, which provides significant throughput in both 2.4 gigahertz and 5 gigahertz radio frequency bands, and it's estimated that it would achieve data transmission speed up to 600 Mbps, which has an access point, is a centralized one where all the wireless devices are connected to an access point. If any node wants to communicate with the other one, the first node has to communicate with the access point, and then the particular access point will transfer the particular data to the other node. That's how the communication happens. So this is suitable for larger to cover larger coverage area. And the next architecture is extended service set. This is made up of 2 or more BSSs, basic service sets, with access points, and these basic service sets, several basic sets, are connected through a distributed system. So ESSs use 2 types of stations, mobile station and stationary station. ESS provides more wider coverage, as well as the users or the devices will be able to roam to get connected to other access points. So this is similar to the concept of cellular communication. Then the MAC layer of this IEEE standard for wireless communication, it has Actually, the MAC layer covers three functional areas of IEEE 802.11. It focuses on reliable data delivery, access control and security. And this IEEE 802.11 defines two sublayers in the MAC layer, which are named as distributed coordination function and point coordination function. So if you look at the it consists of 9 fields as illustrated here. There are 9 fields: frame control, duration, addresses from 1 to 4, and then sequence control, data and cyclic redundancy check. The next topic under this subsection is hidden station problem and exposed station problem. Hidden station problem occurs now if we consider this diagram. Terminal B is in the coverage area of terminal A, as well as terminal B is in the coverage area of terminal C. But A doesn't know that B is connected to the coverage area of C, as well as C doesn't know that B is in the coverage area of A. So when A wants to send some data to B, because A thinks that the medium is free, so that A sends data to B. But at the same time, if C tries to transfer data to B, there will be some congestions. So B gets signals from both A and C devices. So B is the device B is hidden by the device C is hidden by A, as well as device A is hidden by C. This is called as hidden station problem. The other one, exposed station problem, is something like illustrated in this diagram. Now data transmission can be done in between A and B, as well as B and C, without any problem. But the problem occurs now. The device C is exposed to the coverage area of A as well as device B is exposed to the coverage area of A. So therefore, when C and D are communicating with each other, A gets signals from when C and D are communicating with each other, C gets signals from the device A as well. So this is called exposed station problem. Another standard of wireless communication is 802.11b, which provides maximum transmission speed of 11 megabits per second, and it uses 2.4 gigahertz radio frequency range, but it's compatible with the IEEE 802.11g standard. Actually, 802.11g is the popular wireless standard today, which offers transmission speed up to 54 megabits per second, and also this operates in 2.4 gigahertz band, and also it compatible, as mentioned above, it is compatible with 802.11b standard. And the latest standard is 802.11 infrared. Uses infrared light in the range from 800-950 nanometers. Pulse position modulation is the one used here. for modulating, and then 802.11a OFDM, orthogonal frequency division multiplication for signal generation in 5 GHz radio frequency band, and it uses pulse shift key for modulation. 802.11b DSSS, and it is called, it uses HRDSS, that means high rate direct sequence spread spectrum, and actually this HRDSS is similar to DSSS except the coding method used here, and the encoding is used in this specification is called complementary code key. The next standard, the layer is IEEE 802.11g. This is the new specification that defines forward error correction and OFDM using 2.4 GHz frequency band, and it has backward compatibility with the IEEE 802.11b standard, but the modulation could be different. And then it uses non-overlapping channels such as channels 1, 6 and 11 with 25 MHz separation to prevent interferences. Final topic of assessment 2.1 is the Bluetooth architecture layers and its frame format. IEEE standard for Bluetooth is 802.15.1, and it needs less power and less cost for implementation, but it provides lesser transmission speed than Wi-Fi. So Bluetooth is an ad hoc network, that means the network is formed spontaneously, and Bluetooth defines two types of networks, Piconet and Scatanet. Piconet is having maximum of 8 devices. One of them is called the primary and the others are called secondary. Piconets are combined to form Scatanet, so in which one Piconet can be the primary for the other Piconets. Bluetooth contains 3 layers: physical radio layer, baseband layer and the single layer, which is also known as the application layer. And the frame in the baseband layer can be one of the 3 types of 1 slot, 3 slots or 5 slots, such as access code, header. Now we are moving to the next part of the assignment, that is assessment 2.2, which covers the topics such as radio frequency identification, Bluetooth, Zigbee and hotspot like applications, and the light fidelity, the latest one, and then wireless sensor network. So all these applications of wireless communication will be covered in this radio frequency identification, which is also known as RFID, uses electromagnetic fields to automatically identify and track tags which are attached to objects. So these tags contain electronically stored information, and there are 2 types of tags used: active tags and passive tags. Passive tags collect energy from nearby RFID readers, whereas active tags have its own local power source such as battery, and therefore can operate hundreds of meters from RFID reader as well. Applications of RFID, it ranges, it has spread in various fields such as access management and tracking in inventory systems, identification and counting of animals in farmhouses. So all these are done by having a small RFID tag fixed to the particular device or to the particular animal, so that signals sent to capture the location where the animals are loitering. So in self checkout, if the customer passes the RFID detector without paying, it can be identified, as well as toll collection at countless payments, at machine readable travel documents, airport baggage tracking, and then in yard management, shipping and freight and distributed centers to identify the owner of the equipments and undocumented and rolling stocks. And then in some countries, RFDs are used for vehicle registrations, and then to identify equipments in universities and schools. Next form of wireless communication is Bluetooth. That works within a short distance range, approximately it says 33 feet, and Bluetooth builds personal area networks by connecting devices such as mobile phones, headsets, MP3 players, laptops, and GPU units, so many devices, plus digital cameras and printers as well. And the latest version of Bluetooth 5.0 offers greater speed. So as a result of that, this Bluetooth 5.0 can be used in IoT applications. So applications of Bluetooth vary from mobile phones to connect headsets, and to communicate, to provide wireless communication between mobile phones and Bluetooth compatible stereo systems. And then Bluetooth enabled devices, mobile devices like personal digital assistants, PCs and laptops can communicate with each other. And then to locate and the devices, to enable communication with wireless mouse, keyboard, speakers and printers. And then now Bluetooth enabled advertising hoardings can communicate with other Bluetooth devices. And then GPS receivers, medical equipments, barcode readers like devices are replacing the former wired RS-232 serial communication. ZigBee is having the IEEE 802.15.4 standard to create personal area networks, and which is a low power, low bandwidth data communication that enables data communication among the devices which are in close proximity. Similar to Bluetooth, ZigBee is also an ad hoc network where the devices are getting connected spontaneously. And the structure of ZigBee consists of three different types of devices: ZigBee coordinator, router and end devices. Of ZigBee provides the communication link, continue to monitor various parameters in critical equipments, and also in asset management, personal tracking and livestock tracking, and also used in controlling home appliances remotely. And then smart grid monitoring and metering, and also ZigBee is utilized in consumer electronics such as gaming consoles, wireless mouse and wireless remote controls and so on. Applications of RFID, it ranges, it has spread in various fields such as asset management and tracking in inventory systems, identification and counting of animals in farmhouses. So all these are done by having a small RFID tag fixed to the particular device or to the particular animal, so that signals sent to capture the location where the animals are loitering. So in self checkout, if the customer passes the RFID detector without paying, it can be identified, as well as toll collection at countless payments, at machine readable travel documents, airport baggage tracking, and then in yard management, shipping and freight and distributed centers to identify the owner of the equipments and undocumented and rolling stocks. And then in some countries, RFD. The next one is light fidelity, which is abbreviated as Li-Fi, based on the concept of visible light communication systems. So while Wi-Fi uses radio waves, Li-Fi uses visible light. So Li-Fi enables common household LED light bulbs for their transmission at a very high speed, and also it's bidirectional. So these LED bulbs act as the routers in wireless communication. Data transmission is achieved by Li-Fi by using the changes in the light intensity. The on-off activity of the LED bulbs permits a type of data transmission in the form of binary codes which cannot be recognized by the human eye, so that the bulbs appear with a stable intensity. The main advantage of Li-Fi is obviously the high bandwidth. It has been researched that the data rate would be over 224 gigabits per second. Even in the practical situations, it would not be less than 1 second. So therefore, there are upcoming and innovative applications in Li-Fi. So most of the remotely operated underwater vehicles could be communicated with Li-Fi, as the light can travel through water, and then vehicle could communicate with one another by front and back lights to increase road safety. And also street lights and traffic signals could also provide information about current traffic. And then Li-Fi must be the best option at operation theatre, because Li-Fi does not get affected by electromagnetic radio waves. And also applications in sensitive areas, power plants, or maybe some other critical areas. So there are some more innovative applications of Li-Fi. The next topic is wireless sensor network. It can be defined as a widely spread network of sensors which enables monitoring, recording of physical or environmental data and communicating them over a wireless network to a central server. So WSN, wireless sensor network, measures environmental conditions such as temperature, humidity, sound, wind, and all this. And the data collected by the nodes, that means the sensors, are forwarded to the gateway which is connected to the other networks. Applications of wireless sensor networks are medical field, such as implanted wearable and environment embedded systems that are capable of gathering data about body position, movement, location, and the patients. And also transport systems for monitoring traffic, dynamic route management, and monitoring of parking lots, etc. And also to monitor various parameters in the environment. as mentioned before. So most of these wireless sensor networks are used in Internet of Things. Here we move to the assessment 2.3 that basically covers how to design a wireless LAN, what are the Wi-Fi channels, and then how to set up the wireless router. Is done on site and which requires physical walkthrough of the environment that is being surveyed. So this is a bit costly, but because of the administrative overhead required. And we are using a tool to draw the heat map. It's a map of wireless signal coverage and strength. So this wireless heat map shows the real map of room flow over the city overlaid by the graphical representation of wireless signals. So example of such softwares used for creating heat map are NetSpot and VisiWave site survey like softwares. Then we move to Wi-Fi channels. So IEEE 802.11 standard provides distinct radio frequency ranges to use Wi-Fi. There are two ranges of that, 2.4 gigahertz and 5 gigahertz. So each range is divided into multitude channels. So 2.4 gigahertz frequency range has 14 channels, whereas 5 gigahertz range has 23 channels. So 5 gigahertz network is faster than 2.4 gigahertz, but 2.4 gigahertz provides more coverage. So when you consider this radio frequency signals, either 2.4 gigahertz band or 5 gigahertz band, there are interferences in these channels. One of them is co-channel interference. When several devices try to communicate on the same channel, co-channel interference occurs. The adjacent channel interference is the other interference type, which occurs when devices from overlapping channels are trying to talk over each other. So therefore, when selecting Wi-Fi channels to set up the wireless LAN, it is advised to select non-overlapping channels. So it's advised to select channels such as 1, 6 and 11 to avoid this adjacent channel interference. Its default password should be changed, and then unique IP address, network subnet mask, gateway address and DNS server should be manually set up. And then now usually a wireless router should be enabled by default. If it is not, it has to be turned on. And if the router is dual band router, so both 2.4 gigahertz and 5 gigahertz ranges should be configured independently. And then make sure that the channels are set to auto and leave the mode in its default setting. And after that, SSID, that's the name of the wireless LAN, should be specified. And then the last stage is decide about the encryption, or set the encryption. This is done for security purpose in transmitting data over the wireless network. The best encryption is WAP2. Next one is Wi-Fi controller. This provides a single point of management for all the access points by simplifying the management of all these access points while providing mobility services to the wireless LAN users. And also it provides access point configuration as well as acts or functions as a switch for all the wireless traffic in the wireless LAN. and also it enables interference detections and avoidance, load balancing, and load balancing for multiple access points. Further, it facilitates better coverage and data rate. And some wireless LAN controllers perform functions such as stateful firewall between wired and wireless networks, VPN connectivity, etc. And having a wireless Wi-Fi controller will give advantages to the wireless LAN, such as it improves the scalability, allow installation of more APs, flexibility in installing more AP access points, and then it reduces deployment and management complexities. It does all these things automatically, and it reduces overall operational expenses. Likewise, there are so many advantages of having a Wi-Fi. The last sub component of the assessment 2 is assessment 2.4. Here we focus about wireless security protocols and the MIMO antenna. There are three wireless security protocols. WEP, wireless equivalent privacy. The main objective was to prevent hackers from snooping on wireless data when data is being transmitted on via the access points, but and it used 64-bit and 128-bit encryption key, but it should be manually entered on wireless access points, and that does not get changed. So therefore, eventually, cybersecurity experts identified several security flaws in wireless equivalent privacy. So therefore, it has been phased out. So as a replacement for WEP, wireless equivalent privacy, Wi-Fi protected access, WPA, was introduced, which responds to the weaknesses found in WEP. Actually, the most current WPA implementations use pre-shared key, PSK, which is referred as WPA personal, and there's another key used that is called temporal key integrity protocol for encryption. So unlike in WEP, this wireless Wi-Fi protected access uses 256-bit keys, and also it generates unit key for each and every packet dynamically, so that it's more secure. And the next protocol is Wi-Fi protected access 2, WPA2, which uses advanced encryption standard for encryption, and also CCMP, which means cipher block chaining message authentication code protocol, that protects data confidentiality by allowing only one authorized network users to receive data, and it ensures message integrity as well. WPA2, wireless Wi-Fi protected access 2, introduce more seamless roaming, allowing clients to move from one access point to another on the same network without having to re-authenticate. So this is the latest one, or this is the one we are using in most of the wireless LANs as the security. MIMO antenna stands for multiple input, multiple output antenna. Refers to the antenna that are used to send and receive more than one data signals simultaneously over same radio channel by exporting multiple path propagation. As a result of MIMO, data throughput and the range have been greatly increased, and also utilized in therefore this MIMO antennas are utilized in IEEE 802.11 in wireless networks or Wi-Fi networks. And also MIMO improves link reliability and provides less failure. Of the assessment